So I'm Tim Muldoon. I'm a professor in biomedical engineering. So I've been here since 2012, and we'll talk a little bit about the history of this particular class and our specific implementation of it here in a second. But Mostafa, if you'd like to maybe introduce yourself, we can kick it off there.
Yes, Mostafa Elsaadany. A teaching associate professor here in the Department of Biomedical Engineering, University of Arkansas. I started in 2019.
All right. So away we go. So I always want to try to kind of articulate a little bit about our department, our university, and sort of where we're from exactly. So I'm not a native Arkansan, and the first time I really set foot in Arkansas was when I came to interview for my faculty job here. So, and I think the only city that I could have named was Little Rock. And so I guess what I want to make sure is that, so we're not in Little Rock. We're in the northwest corner of Arkansas, in Fayetteville, actually much closer to the Bentonville home of Walmart than we are Little Rock. And so that hopefully gives some context for kind of where we're at. Our department, like I said, was founded in 2012. We're now up to 15 full-time faculty. We have a common first-year engineering program. I think many of you all are probably familiar with that structure. And so I'm only counting our sophomore, junior, senior students here. So we have about 250 total undergraduate students among those three classes. So that gives a class size, and it's ranged over the years, probably between high 60s to low to mid 80s. And now we're up to over 70 graduate students, 70 to 80 graduate students, PhD and masters. This is just sort of a general, again, kind of contextual slide here. Sorry, the map is a little bit grainy. But overall, just to consider the overall kind of structure of where we are. We're not at a major urban center really just yet, but Fayetteville's not small either. We have about 100,000 people in Fayetteville proper, and this whole sort of corridor now has grown to somewhere on the order of 400,000. I've heard 500,000 quoted as well. It's expected that this region of Arkansas is going to get close to the size of Charlottesville, North Carolina, at some point in the next 10 years or so. So this is a pretty fast-growing region of the country. The University of Arkansas, we're a big land grant state university, pretty undergraduate heavy focus. You can see the numbers there. I think those are maybe not the most accurate up to this year, but pretty close to where we are, about 32,000 total and 27,000 undergraduates. That number has increased quite a bit over the time that I've been here. I think when I first started, we were in the low 20,000s total. So the undergraduate enrollment has expanded significantly in the last decade. Again, so kind of reflecting the growth in the area and the priorities of the administration here. So we are 3 hours from Little Rock, and there are several hospitals and primary care facilities in the greater kind of Fayetteville metro area. Those are the little red dots I've got mapped out there. But I want to mention that there's not a major teaching hospital really right next door. So the main medical school is located in Little Rock, University of Arkansas for Medical Sciences. That's where they have their main tertiary care center. They have the research and teaching hospitals are down there. There's Arkansas Children's Hospital, which is also based in Little Rock, and they're closely affiliated with the University of Arkansas system as well. One thing that's kind of emerging that is newish to the area is the Alice Walton School of Medicine. And yes, they like to use the acronym AWSOM for awesome. I'll save my thoughts on that for later, but that's opening in fall 2025. So that is not necessarily going to be like an immediate huge teaching hospital or anything like that, from what I understand. But that does present maybe an opportunity as that system starts to come online for maybe some future clinical experiences for some of our students as well. Okay, so a little bit of an overview of the clinical sites that we've sort of partnered with so far here. And, many of these names you may not be particularly familiar with, but let me just kind of walk through some of the major areas that we interact with and that we send our students to. So UAMS does have a branch up here in Northwest Arkansas. But they're primarily focused on primary care, ambulatory care type settings. So they have a physical therapy clinic, they have a community internal medicine clinic, and those are pretty good resources. And they're obviously very education focused. They have medical residents that actually rotate through their internal medicine clinic. And so I think because they are a very closely related kind of Arkansas system school, very heavily focused on education, they've been very steady and willing to accept our biomedical engineering students for observation sessions. So it's been great to work with them. But those are the two kind of fields that are heavily represented out of those more academic centers. So physical therapy and internal medicine, and you know those drive a lot of the projects that kind of come out of this particular class. A couple of other things that we partnered with here, the University of Arkansas itself, like at our institution, does have a nursing school, and they have a nursing simulation lab. And so I got in touch with them, and they have things like mannequins where the nursing students learn how to do venipuncture, starting central lines, and things like that. And I thought that was kind of an interesting take to get the students to start to think about projects that are more education focused rather than directly like patient care related. And there's been some interesting things that have come out of that concept as well. We have a couple of private clinics. I'm just mentioning one here. It's an orthopedic surgeon who works out of Northwest Arkansas. He's been great to work with as well. And you can imagine, somebody who sees a lot of ACL injuries, those types of projects kind of parallel a lot of what we see coming out of the physical therapy clinic as well. And something that I haven't really mentioned here is that we have quite a few industry partners as well. And maybe I'll go on to the next slide here and I can talk a little bit about that too. Okay, so the clinical observation class that we have, the way that it's structured, I think is pretty conventional overall. We have a lecture series. It's a once a week lecture that I kind of put together. We kind of talk about a lot of different things from design elements to FDA device regulation to needs finding. That's the other kind of title of the class is how to identify a need properly. And we have somebody from our business and entrepreneurial side now coming and giving a guest lecture on needs finding in particular. And that's been a nice thing, a nice addition, I think, for the students to start to learn about human-centered design and those kinds of related concepts. So I try to keep that fresh as best I can. The clinical observations are sort of based on the sites that I just mentioned. The other thing that I wanted to kind of briefly touch on is that we do have some industry partners that are very generous with their time, and they will host virtual meetings with our students as well. So these are things like Smith and Nephew. They're based out of Memphis. They do a lot of orthopedic implants. We had a company called Nuvasive that does spinal implants. Both of those companies actually have representatives that are on our department advisory board. So that's kind of how we got in touch with them and got them engaged. And I think that serves two roles where the students coming from this clinical observations class get to ask about, okay, well, how do you go about addressing a need that a clinician has identified from an engineer's perspective? We also ask them things like, well, tell us about some of the ethical considerations maybe that you had or technical things. But this is also an opportunity for students to get some exposure to like professional development. What's it going to look like when you're working in a medical device company? We have a whole lot of people who do research in our department, conventional laboratory research and so forth. But we want students to kind of see what it's like in the a little bit more in the real world. And so the addition of those industry partners has been very helpful. So through this class, the class is sort of arranged in kind of two phases. So the first half of the class is where the students will do all of these individual observations, and then they come up with on an individual basis, they come up with a project concept. And I let them kind of have a wide latitude with this. They can come up with anything that is reasonably practical, but it needs to be motivated from some kind of clinician input from somebody that they talked to in one of their clinical observations. And so that becomes like their midterm assignment, essentially, where they write up a summary of their visits and then also introduce the project concept that they have. Eventually, we kind of down select this a little bit, start to merge these into projects that could realistically form the nucleus for a future senior design project. And the students begin to work in groups at that point. So I either partner them together or form groups of three around common themes that I think are reasonably well developed and themes that could go on to become future senior design projects. And yeah, like I said, students of 2 to 3 student member teams are created there. And then eventually those projects, again, based on what our senior design instructors are looking for, those might go on to be projects that they'll use in the future semester. I kind of skipped over this. I didn't mention that this is a junior level class. I think that probably most implementations of a clinical immersion, clinical observation class are probably similar because you want to get that, before they get to their senior design or capstone type course. But that's where that fits in for us as well. It's in their junior year. This is kind of a boring looking slide. I just want to sort of mention the kind of key learning objectives that we're looking for here. And again, I think these are probably pretty conventional based on what other people have done and described in other clinical observations courses. To learn how to understand, how can you use your biomedical engineering knowledge to solve a meaningful problem, and how do you go from an idea to at least prototyping a potential future product. We talked a little bit about FDA regulation, ethical considerations. Recently, we have involved a little bit more of, like I said, human-centered design and maybe some commercialization concepts as well. I know in senior design, they cover quite a bit more of intellectual property and those types of considerations as well. And then a big thing that I try to make a point in this class is to get the students to understand how to present and communicate their ideas effectively in a professional setting. That's a little bit more subjective, of course, but something that I try to make sure is clear from the beginning. So I work with them, especially towards the latter half of the class, to try to figure out how to present that in an effective way. So one of the things, I think maybe the main thing that we were interested in discussing today with everybody, and this is some points that we can kind of have a more open conversation with later, is how do we measure the efficacy of this class, kind of broadly defined? Again, there's probably many different ways of going about this, but I picked two projects or two key questions that Mostafa and I have sort of been working on in the last couple of years. So I'll talk a little bit about this question one here, and then Mostafa is going to step in with question two. But question one is mostly about what do the students feel like they're learning or getting from this particular class? And so, we kind of broke this down into two kind of common methodologies that I bet several of you all are applying to your classes as well. So the somewhat simpler implementation of asking, collecting data for a question like this is basically a Qualtrics managed student survey. We send this out at the beginning of class, like the first week of class, and then at the very end of class. And in order to incentivize the students, I make it a 5-point assignment for the beginning and 5 points for the end. So I've had pretty good compliance, I guess I gotta say, like that, probably 90-some% of them actually do it. Mostafa has been super patient and worked his way through the IRB to make this all on the up and up. There's some, well, I'll keep that to myself later, but that always is a fun process to deal with a lot of back and forth with them. But that's been good. And so the Qualtrics thing is sort of focused on two major kind of things here. One is the more conventional kind of categorical type questions, Likert style responses. So we've got a 5-point Likert scale for some of these individual questions. And then we have these open-ended free response questions in this. We use this in vivo commercial software which helps us kind of assess this qualitative data. And I think Mostafa could probably talk a little bit more about the results and kind of the implementation of this in a couple of slides. We'll show you kind of how we synthesize those results for some of those questions later on. So I'll talk a little bit about this question one here over the next slide or two, and then I'll hand this off to Mostafa to kind of bring it home. So in terms of like these couple, and I'm not showing all of the questions that we ask about in terms of the Qualtrics survey. So these are just some where we felt there were some significant changes between our pre-course survey, that one that goes out in the first week, and then the post-course survey. So these are just some pretty basic but fundamental questions that I think really try to drive home, like, is this course providing some value to you, right? And so, the students asked, can I, asked to assess their ability to provide engineering solutions, and then can they identify a test to improve a product? And I think, both of those are pretty important skills going into and coming out of senior design. The blue basically means they strongly agree. Green means they agree, and there's a lot more blue and green. So you can see, okay, well, we can kind of start to quantify perhaps like how the students feel about their improved skills before and after the class. Value creation here. This is, again, something I think very important for a lot of the commercialization angle of these things. I can understand the motivations and perspectives of customers. I was kind of surprised that their pre-course, they were very confident of that, I guess, in the beginning. So I don't know that we made a huge improvement in that, but they're already pretty confident of that. And then the next one was, how do I learned how to make connections with what I learned in class and real world engineering problems. Again, they started out pretty positive about their about their skills in that area. So I guess we improved a little bit, but I thought that was sort of interesting to see. And then real quick, because it's going to lead into Mostafa's part here, is just to give kind of a quick overview of like the demographics of our department and the university where we are. So I guess just if you look at the right-hand side, and this is probably similar among all biomedical engineering programs, we're probably a little bit more balanced in terms of male-female ratio than many of the other engineering departments. I'm guessing that's probably a little bit more universal, but we're almost 50-50 with that as opposed to the rest of the College of Engineering. But in terms of underrepresented minoritized groups, that still lags significantly and is sort of in parallel with the rest of the College of Engineering. So for University of Arkansas uses 4 letters to abbreviate their department, so that's why we are BMEG and not just BM. It took me a while to get used to that. Okay, so I think with that, I'll hand this off to Mostafa. So Mostafa, just tell me when you want to jump to the next slide, and I'll be ahead for you.
So a few things that I wanted to mention here before I discuss more results. So in terms of the clinical needs finding course, I think we started this in 2018. The goal here is to prepare senior design students to work on clinically relevant and some real world problems that they solve in senior design. Later on, I created a class called Entrepreneurial Bioengineering. And what we do, as Tim mentioned, the clinical needs course, the students identify a problem, and let's say we come up with, over the course of the year, 20 problems. So Tim and the instructors of senior design, I was teaching senior design the previous years, we meet and then identify, let's say, 10 projects from clinical needs that we feel appropriate or they have some significance. So from these 10 projects, I offer these projects into my entrepreneurial bioengineering class, where the students do customer discovery, very similar to what you guys are familiar with the iCore NSF program. So they do like a mini iCore in this class. So the goal here is to validate the problem in my class, and then they already started a little bit with this in clinical needs, but they do further research and validating the problem. And along with that, in parallel, they validate the solution in the senior design course. So these three courses work together, and we have seen uh, a great increase in the number of patent applications that come out that come from the students in biomedical engineering. We have also seen great collaborations with clinical partners, so clinical doctors, physicians, working with our students to complete these projects. And actually, some of them went ahead to national NSF I-Core. So um, um, this is just a little bit of background, and also Tim mentioned the human-centered design aspect that we started to include last year. So that also brings more um, kind of real world kind of flavor into the class. And we collaborate with people from our Bolton Business School for that purpose. One more thing before I mention that, I know Tim mentioned why do we see good pre-course, why do we see higher numbers? So the reason is we have been doing I know you guys are familiar with Keen framework, the entrepreneurially minded learning aspect. So we have started incorporating email modules in the biomechanical engineering course, which is a sophomore level class. So the students take this before clinical needs finding. So the students enter the course with already some familiarity with the Keen framework, value creation, curiosity, and all of these things. So this is just wanted to make sure you guys are familiar, just to put that into perspective. So first couple of years, we wanted to see how the course is effective, generally speaking. And we have collected extensive amount of data. We presented this a couple of times in ASAA, but then we wanted to see if that course is inclusive based on the demographics that you see here. So we have about 20% students from historically marginalized groups. So historically marginalized groups in our terms is African American students, Asian, not Asian actually, Asian is well represented in engineering, at least at University of Arkansas. So African American, Hispanic, female students, and first generation college students. So first generation college students, we also have about 20% of our student body from first generation. So we wanted to see, especially at this very critical stage in the students' career as biomedical engineering students, we wanted to see if that course is touching all the students equally. So we started to look into how students from historically marginalized groups respond to some questions and again we used Qualtrics surveys, both large scale and also open response qualitative questions. So we looked first at how students from historically marginalized groups based on race, how they have responded to a question like, I can design products to solve a real world problem. So again, the motivation here is we have 50% female students in our department, 20% first generation, and 20% students from historically marginalized groups. And research shows that, especially for female students, they come into the engineering classrooms with stereotype threats. So the things that you can think that are normal, the students actually get triggered a lot by some of the things we unintentionally doing in the classroom. So we really wanted to make sure that yes, these positive results that we obtained for the course overall is the same pretty much between all the students. So results that you see here is for pre and post for historically marginalized groups versus non-historically marginalized groups. Um, the, the, the bottom line is all the students enters a class with pretty good kind of confidence, self-confidence, as you see here from 3.58 to 3.67. It's not very low in terms of the students actually working in solving real-world problem, again, because we as a department have started early to introduce these entrepreneurially minded learning modules in their sophomore year. But still, we have seen improvement after the clinical needs finding course in terms of this self-confidence. Students from historically marginalized groups enter the course with lower confidence, despite high, generally speaking, but lower compared to the other non-historically marginalized groups. So and after the course, again, because of our intentional interventions, we have seen that better improvement for these students compared to their counterparts. We have also looked at gender and first generation college student status, and we have seen also similar trend from a quantitative perspective, especially for gender female, because our department has 50% female students. If you look at the pre course, 3.9 self-confidence compared to 4.9 for male students. So the female students enters the course with lower self-confidence compared to the female to male students. But after the course, we see a significant improvement. Again, this can be interpreted by students seeing examples. So they go to these clinics, they see female healthcare professionals, they see healthcare professionals from marginalized groups, and they get exposed to these kind of situations. So that can be used to interpret this. Um, as Tim mentioned, we also have been exploring qualitative analysis. So this was sort of a scary area for all of us at the beginning. So we have collected these open response questions from the very beginning. Tim and I started working on engineering education research in 2020. Actually, we published a paper based on mentoring first generation college students. In that paper, we also collected qualitative analysis, but we were not very, I don't want to say, but we were not very familiar with the tools. So we have learned a lot along the way. And then we started to just to avoid, based on reviewer responses, we in order to avoid researcher bias, we started to explore maybe using a software, and we came across a software called NVivo. It's not cheap, but it's not also very expensive. I think we purchased a lifetime license for about 1,500 or something. So this is not a subscription based software. But it's a one seat kind of license. We put that on a laptop and we all share using it. So we have used NVivo mainly at the beginning to do the results that you see here, what is called sentiment analysis. So we get the questions, we store the data in an Excel sheet, then export it to NVivo, and the software has an algorithm that can um, categorize the responses into positive, negative, and mixed sentiment. And then it gives us a metric. So how much positive, how much negative, and how much mixed. And we did not show the results here, but we have looked at different student groups as well. We have also looked at pre and post. So this is sort of converting the qualitative data into something that we can report quantitatively. But we did not stop there. We have also started to learn how to do regular qualitative analysis coding. So where we do manual coding and just find thematic analysis to see how can we put student in different themes, student responses in different themes and in different categories. Recently, we have also learned in last ASAA conference about a new AI-based software called Atlas. So that software is actually very cheap. So subscription is like 20 or $30, and you don't have to use it. Or you can just use the software for a month or two to analyze the data and get done. It uses AI to do coding and thematic analysis. So we have started to experiment with that as well in order to make sure that our qualitative analysis is consistent and also to avoid bias. Just to summarize the results that you see here is that after the course, majority of the student responses were in the positive kind of sentiment with these three questions that you see here. These are all open response questions, as I mentioned. With that, I would like to acknowledge the students who led this research. Actually, all of them are undergraduate students in our department. Jacqueline, Ali, Lauren, Hud, Maggie, and Dr. Muldoon. Our funding agencies is the National Institute of Health, NIH. We have our R25 grant. Dr. Rao is leading that, and the National Science Foundation, Dr. Muldoon. Thank you all.